let's get real. What truly sets a Tesla apart isn't just the design or speed, it's the battery. This isn't just a power source, it's the heart and brain of the car. Tesla didn't just build an electric car, they reinvented the battery by stringing together thousands of small, powerful cells inspired by laptop batteries. Before Tesla, electric cars were slow, had poor range, and took ages to charge. Tesla's breakthrough was realizing that mastering battery tech was the key to making EVs practical and exciting. They became a battery company as much as a car company. This focus on battery innovation is why Teslas have such impressive range and performance. The battery dictates everything: range, acceleration, and longevity. Tesla's use of thousands of small cylindrical cells allowed for more energy, better heat management, and scalability. They didn't just add a big battery, they engineered an intelligent energy platform from scratch. It's a story of pushing lithium-ion tech to its limits, evolving from the Roadster to today's models. We'll break down how these batteries are built, the types of cells Tesla's used, and the chemistry behind it all. This is a journey of constant innovation and problem-solving. Buckle up, we're diving into the electrifying world of Tesla batteries. Let's bust some myths and uncover what really powers the future. How do you turn a tiny battery cell into a pack that powers a 2-ton car for hundreds of miles? Precision engineering. It starts with individual cells, small building blocks. Tesla arranges thousands of these cells into modules, each with its own electronics for monitoring. This modular design makes assembly easier and improves safety. If a group of cells has an issue, the system can isolate it. Modules are then packed into a large armored case under the car's floor, giving Teslas their low center of gravity and great handling. The battery management system, or BMS, is the brain, constantly monitoring every cell's health, balancing charge and managing temperature. Liquid cooling keeps things from overheating during fast charging or spirited driving. The BMS also calculates your range with impressive accuracy. This intricate system of cells, modules, and smart management is what makes Tesla batteries reliable and powerful. It's not just a battery, it's a symphony of engineering. Every part is designed for performance and longevity. That's the secret behind Tesla's battery magic. Let's rewind to Tesla's first battery hero, the 18650 cell. It's a standard size, 18 mm by 65 mm, used in billions of electronics. Tesla's genius was using this mass-produced cell for cars, starting with the Roadster, Model S, and Model X. Over 7,000 of these cells powered the Model S, giving it unmatched range and performance for its time. The 18650 small size made it easy to cool, allowing for fast charging and high performance. But packing thousands of cells meant lots of connections and complexity. More cells meant more potential failure points and higher manufacturing costs. Still, the 18650 was reliable, affordable, and well understood, a perfect launchpad for Tesla's early success. As Tesla aimed for mass-market cars, they needed something simpler and more efficient. The 18650 had served its purpose. It was time to evolve, enter the next generation. For the Model 3, Tesla needed a battery that was easier and cheaper to build at scale. Enter the 2170 cell, 21 mm by 70 mm, a bigger, better evolution. Developed with Panasonic, the 2170 offered about 50% more energy per cell than the 18650. Fewer cells meant fewer connections, less weight, and lower costs. The Model 3's pack dropped from over 7,000 cells to just over 4,400. This simplified manufacturing and improved reliability. The 2170 became the workhorse for the Model 3, Model Y, and even updated S and X models. Larger cells did pose new thermal challenges, but Tesla refined their cooling and management systems. The result, a battery that balanced cost, simplicity, and performance. The 2170 was key to making Teslas more affordable and accessible. It was a leap forward in battery tech, but Tesla wasn't done innovating. Then came the 4680 cell, a true game changer. At 46 mm by 80 mm, it's much bigger, but the real innovation is the tabless design. Traditional cells use tabs to connect the anode and cathode, creating resistance and heat. The 4680's tabless, shingled spiral design allows current to flow more freely, reducing heat and boosting efficiency. This means faster charging, more power, and less energy wasted. Each 4,680 cell packs 5 times the energy and 16 times the power of a 2170. Fewer, larger cells make for simpler, lighter packs. The 4,680 is also structural. The battery pack becomes a part of the car's frame, improving strength and reducing weight. This design is rolling out in vehicles like the Cybertruck and some Model Ys. The 4,680 isn't just a new cell, it's a new way to build cars. It points to a future of even more powerful, affordable EVs. Tesla keeps pushing the boundaries. The battery revolution continues. Now let's talk chemistry. What's inside those cells matters as much as their shape. Tesla's longtime favorite is NCA, nickel cobalt aluminum. NCA offers high energy density, enabling long range and fast acceleration. But cobalt is expensive and ethically problematic, so Tesla works to minimize its use. NCA batteries are sensitive to high charge levels and can degrade faster if always charged to 100%. Enter LFP lithium iron phosphate. LFP is cheaper, uses no cobalt or nickel, and is extremely durable. It's used in standard range Model 3 and Y. LFP batteries can be charged to 100% daily with little degradation. The trade-off? Lower energy density, so less range for the same size. Each chemistry has its place in Tesla's lineup. Let's pit NCA and LFP head-to-head. NCA's strength, high energy density, more range, lighter packs, and top performance. Downside, higher cost, reliance on cobalt and nickel, and more sensitivity to charging habits. Tesla recommends charging NCA packs to 80–90% for daily use. LFP's strength, durability, and cost. You can charge to 100% every day, and it's cheaper to produce. LFP is also safer and less prone to overheating. Downside, lower energy density, so it's used in standard range models. LFP can be sluggish in cold weather, but preconditioning helps. The choice comes down to priorities: max range and performance, or cost and longevity. Tesla offers both, letting drivers pick what matters most. It's all about matching the right chemistry to the right car. That's smart battery strategy. Zooming out, Tesla's battery strategy is all about vertical integration and relentless innovation. They design, engineer, and manufacture their own cells and packs, giving them unmatched control. This lets them push boundaries with new formats and chemistries, and tightly integrate batteries with software and charging networks. The result: efficient, powerful, and reliable battery systems. The structural pack concept makes cars lighter, stronger, and cheaper to build. But scaling up is a huge challenge. Battery shortages can slow production. The structural pack could also make repairs trickier and more expensive. Tesla's ecosystem is tightly controlled, which limits third-party repairs but ensures a seamless experience. Still, the pros far outweigh the cons. Tesla's battery innovation drives their success and pushes the whole industry forward. That's the real power behind the brand. What's next? Tesla never stops innovating. The 4,680 cell is just the start. Tesla's working to drive costs down even further. New manufacturing methods like dry coating electrodes could make batteries cheaper and greener. Expect ongoing chemistry improvements, less cobalt, maybe even sodium-ion or solid-state batteries in the future. The structural pack will keep evolving, making cars lighter and simpler to build. Imagine a battery that's the car's floor and frame, reducing parts and boosting efficiency. Tesla's ethos: question everything, innovate relentlessly. From 18650 to 4680, NCA to LFP, the evolution is breathtaking. Tomorrow's battery will make today's look ancient. The future of electric driving is brighter and closer than ever.